Hello again, welcome back. These will be the notes for 4.2, Graphing Linear Equations. There is a PDF available if you'd like to go ahead and download that. First thing I want to talk about is what is a linear equation. An equation which typically involves a two-variable relationship. The variables x and y are the most common variables used in that relationship so that they may be graphed on a coordinate plane, the x and y axis plane that we did on the previous notes. The highest exponent that is used in this relationship is a 1, and this is the reason that we call this a linear equation or a linear relationship. If our exponents are higher than 1, then it's no longer linear. This is the standard form, ax plus by equals c. And the one thing about A, B, and C is they all have to be integer values. And some people require that the leading coefficient has to be a positive. That really depends on the teacher. But you can leave it positive or leave it negative. It's really up to you. Linear function is just another name for a linear equation. However, when you hear the word linear function, it's usually written so that y is by itself, or in other cases, you might see it in what's known as function notation, f of x equals. But the f of x is really interchangeable with y. And you'll see two examples there, y equals 2x plus 4, or f of x equals 2x plus 4. Those two equations actually represent the same solution or line on a graph. Example number 1, are the following ordered pairs a solution for the equation of 2x plus y equals 10? We're going to start with A. This is the x value, this is the y value. So basically what we're going to do is substitute 5 in for x. We're going to substitute 0 in for y and test to see that the left-hand side is equal to 10. So we have 10 plus 0 equals 10. That checks out. Therefore, this is a solution. Now we're going to go ahead and check the next one. Put a negative 3 in there, plus 4 in place of x and y. Again, this is x and this is y. And check to see that that equals 10. We have a negative 6 plus 4 equals 10. Well, negative 6 plus 4 is going to give us a negative 2. That does not equal 10. So this one does not check out. So this one is a no. And the last one, we're going to substitute a negative 4 in for x and an 18 in for y. And check to see that that equals 10. Well, this is negative 8 plus 18. And negative 8 plus 18 does equal 10. So this one checks out also. So this is a yes. So in order to calculate or determine if ordered pairs are a solution, you have to substitute x and y in and see if the equation is still true. Example 2, we want to graph negative 2x plus 3y equals 6. Well, the first thing we need to do is rewrite this so that y is by itself. So I'm going to bring the x over here, and I'm actually going to make room for the x up front. So my 3y is going to equal positive 2x plus 6. I like to have the x up in the front. It's not necessary, but it's a negative 2x on this side. So to undo it from that side, we're going to add 2x, but I have to add 2x to the other side as well. Now I still have to get rid of the 3, and one of the ways we're going to get rid of the 3 is we're going to multiply by the reciprocal, which is 1/3, and then I'm going to multiply this side by the reciprocal, which is 1/3. So I'm going to distribute here and here. Well, 1/3 of 3 is 1. 1 times y is y. 1/3 times the 2 here gives us 2/3 x, and I'm going to have a positive times positives. That leaves it as a positive, so 6 times a third gives us 2. Now in order to graph this though, I need to come up with some points. We have x values here, y values there. We also refer to this as domain and range. On the previous example, we talked about x being the domain, also the input value. So I'm going to pick some input values. The first one I'm going to pick is 0, because 0 is always easy to use. 2/3, I'm going to put 0 right in place of x and calculate. 2/3 times 0 is 0. 0 plus 2 gives you a value of 2. So a domain of 0 produces a range of 2. And I can actually go and calculate that. 0, 2, or not calculate, I can graph that on the graph. 0, 2 would be located right here. Now I got to come up with a couple other points. It's always good to come up with a minimum of 3. 2 is actually all that's needed to create a straight line, but the third one is just to ensure that you didn't make any miscalculations. Now when I go to select my next domain value or x value, you'll notice that the denominator here is a 3. So what I want to do is choose multiples of 3 for x. So I'm going to choose a 3 and a 6. So substitute 3 in place of x, so I have 2/3 times 3 plus 2, and this whole thing is going to equal y. Well, 2/3 times 3 is 2, and 2 plus 2 gives us 4. 3's will cancel out, leaving 2 plus 2, which is 4. So I have an input or domain of 3 and a range of 4, so I'm going to go count 1, 2, 3, and up 1, 2, 3, 4, and where they intersect is where my line is, or my dot is. Put a 6 in there, so 2/3 of 6 plus 2 will give my new range, given a domain of 6. So 6 divided by 3 is 2. 2 times the 2 on the top is 4. 4 plus the 2 that's out here gives us 6. So 6, 6 will be on my graph. I've already got 3, 4, 5, 6. This is already 4, 5, 6. And where those two intersect is right here. And you can see that they actually do line up in a straight line. So I'm going to go ahead and do the best I can here to draw my line in opposite directions. And keep in mind that the line simply represents every XY ordered pair that is a solution for the original equation. So the line represents all the ordered pairs, XY's, that will make the original equation true. Example 3, we want to write the following equation, this one over here. We want to write it in standard form, and I do have standard form at the top there, ax plus by equals c. Keep in mind that a, b, and c have to be integer values, and the first thing you'll notice is that a and b are on the same side together. So what I need to do is take my 3/5 x and move it over here with the y. Well, it's a positive 3/5 x on the right, so it's going to become a negative 3/5 x. I still have a positive y is equal to 6. Now we have the x and the y on the same side. However, my a value, which is this one out in front here, is a fraction. And a, b, and c, the b value here, by the way, is 1. A, b, and c are supposed to be integers. So what I have to do is clear the 3/5 fraction. In order to clear that 5, I have to multiply everything in my equation by 5. So 5 times negative 3/5 leaves you with negative 3x. So I multiply here, and then multiply here. 5 times 1y leaves you with 5y. And I still have to multiply the other side by 5. Every term has to be multiplied by 5. 6 times 5 gives us 30. Now officially that is the standard form. However, I did mention that some people don't like the leading coefficient to be negative. So if you don't want that leading coefficient to be negative, you take it one more step further and you multiply by -1. And all that really does is change the signs of every number. So negative 3x becomes a positive 3x, and a plus 5y becomes a minus 5y, and a positive 30 simply becomes negative 30. So either of these answers would actually be okay, the one up here or the one down here. The one thing you cannot have is fractions in a standard form problem. The next one, example 4, is talking about special graphs. They want us to graph y equals b and x equals a. These two things here, this one and this one, You have to kind of commit those to memory. If you're given a y value only, what you end up having is a horizontal line. And if you're given a x value only, you end up with a vertical line. So we're going to go ahead and graph. So I'm going to use red for the y. So what this equation is saying is no matter what xy value you choose, the y value always has to remain -4. So I can pick any number I want for x. So let's put a 0 in there. Let's go ahead and pick another one. If I put -4 there, that's what this equation is saying, is y always has to be -4. And then let's put in, let's say, 3. If I were to graph those points, 0, -4, 0, 1, 2, 3, 4, -4 would be here, and then 3, -4 would be over 1, 2, 3, but would be down here. The only way you can draw a line through those two dots would be a horizontal line. So if you have trouble remembering that y by itself equals a horizontal line, just remember as this equation is simply saying all of your y values have to be that number. So no matter what number you put in for x, you can go graph them, you'll see you can only make a horizontal line out of it. The same is true for x equals 5. They're saying there that no matter what you choose for y, the x value has to be 5. So let's pick some numbers there. Let's pick 0 there, and let's do a +3 here. So plot 5, 0. So that would be 1, 2, 3, 4, 5. One dot there. And then 5, 3. Same location, 5 over there. And then we got 1, 2, 3 up. And that would create a dot there. And the only way you can draw a straight line between those 2 points would be to draw a vertical line. So this is the line or the graph of x equals 5. And the other one over here is the graph of y equals -4. That's a common mistake made by algebra students. The best thing to do is just memorize it or understand what was explained right here. Example 5, graph the function. Basically, this is nothing more than what we did a couple examples ago. The difference is instead of calling it an equation, we're calling it a function because y is simply isolated by itself. Now we still have to come up with a table of values. I got a domain value, a range value. And remember, domain is the same thing as x, and range is the same thing as the y value. Now anytime you have an x, a good domain to start with would be 0. You'll also notice I have a fraction here that has a denominator of 2. So what I want to do is pick some other numbers for x, or my domain values that are multiples of 2. So I'm going to choose 4 and -4. All I got to do now is calculate my values. So put a 0 in place of x times -1/2 plus 4. And that gives you 0 plus 4, which is 4. So I'm going to go plot 0, 4. 0, 1, 2, 3, 4. That would be right here. Do this again with a +4 in for x plus 4. -1/2 times 4 gives you -2. -2 plus 4 gives you +2. So 4, +2, so over 1, 2, 3, 4, up 2 would be right here. And do it again with a -4 for my domain value, or my x value, whatever you want to refer to it as. Put a -4 here, plus 4. So a negative times a negative is going to be a positive. 1/2 times 4 is 2. 2 plus 4 gives me an output or a range value of 6. So -4, 1, 2, 3, 4, and then I got to go up 1, 2, 3, 4, 5, 6, and where those intersect would be my dot. And if I did it right, you can see that my points are actually lined up in a straight line. This would be the graph of that function, keeping in mind that the line itself simply represents all the possible values that work for the original equation or function. Example 6. running, the distance d in miles that a runner travels is given by the function d equals 6t. Well, they have d here by itself. That's the dependent variable, so we can call that y. And they have the t on the other side. That's our independent variable. We can call that x. So I'm going to put a t here instead of an x, and I'm going to put a d for distance. It's really input, output, which is domain and range, x and y. Where t is the time in hours spent running. The runner plans to go for a 1.5 hour run. So the runner hopes to go a maximum of 1.5 hours. Graph the function and identify its domain and range. Okay, so we already know that the runner wants to go for a maximum of 1.5 hours. So if I go and put in place of t, 6 times 1.5, 6 times 1.5 should give us 9. Yep, it gives us 9. The distance would be 9, so 1.5 is my t value. So instead of x over here, I'm going to put t, and my y value, instead of y, I'm going to put d. So I have a 1.5, 1.5, and then up 1, 2, 3, 4, 5, 6, 7, 8, 9 would be right here, right about the middle. Let me get rid of this so it doesn't confuse you. I got to find my minimum time. Well, that would be a 0 time. So 0 times 6 gives you 0. So the minimum distance would be 0. 0, 0 would be right here. And let's pick a value somewhere in between. Let's go with, let's say 1. So if I substitute a 1 in place of t, 6 times 1 is 6. 1 hour and 6 miles. So over 1 and up 1, 2, 3, 4, 5, 6. So as you can see, we end up having a very steep line here. But we're not going to put arrowheads on the ends because this line is not going to go on infinitely. We know that the runner can start at 0 hours, and that's the minimum, and is only going to run a maximum of 1.5 hours, which gives us a distance of 9. So we have 0 down here and 9. So they want us to graph the function and identify the domain and range. Okay, so the domain is our t values. So we can either put a t or we can put a d for domain. Well, we know that the time value is greater than or equal to 0 hours, and at the same time less than or equal to a maximum of 9. So we're basically looking for a min and a max value. That's the domain, though. They want us to also tell what the range values are. The range values, again, were the distances depending on how long we ran for. So I'm going to use d. We could use y. And I know if I ran 0 hours, my minimum distance would be 0. So greater than or equal to 0. And, oops, I made a mistake up here. Time value. The maximum time value was actually 1.5. Go back and change that. If you didn't make that change, please. Anyway, the maximum time value was 1.5, which produced a maximum distance or range value of 9 miles. So this right here would represent our minimum and maximum domain and range values. The graph does not go on infinitely, therefore there is a definite begin and end to both the domain and the range.